the fourth and final part of our video series on projectile motion. In this part, we're really going to be you're really going to have a chance to test how well you understand this topic of projectile motion. So make sure that you've watched the previous 3 sections, and because by now you should definitely be aware of how to separate the motion into horizontal and vertical components, or how to combine horizontal and vertical components to find the resultant. You should also be very well acquainted with recognizing the key features of projectile motion, especially about the acceleration and the velocity sections. And you should be developing the skills and ability to solve problems by using the appropriate kinematic equations. So now it's time to check your understanding. In this question, we have a ball that is rolling horizontally with a velocity of 3 meters per second. This ball falls off of a cliff 10 meters high. How long will it take to hit the ground? Well, just to give you a little bit of a starting point, it is strongly advised that you use a table like this to fill in your horizontal and your vertical known values. Pause the video here and take as long as you need to find your answer to the question. Okay, so reading the question, the key is to recognize that 3 meters per second is referring to the horizontal motion, whereas 10 meters is referring to the vertical height. And this is a negative distance because it's falling down. Therefore, we have a velocity of 3 meters per second in our horizontal column, and we have a distance of -10 in our vertical. Remember that the acceleration is always -9.8. Now, the key here, again, is to recognize that this 3 is referring to our horizontal motion, but actually we're interested in our vertical motion, and it's actually it's not falling at all. It's got 0 velocity in the vertical at this initial point. Now that we have an initial velocity, an acceleration, and a distance, that's three known values. 3 known values is what we need to solve any value in kinematics. So what we want to find is how long it will take, which is time. But we do not know VF. So the same way we did last time, we have to rule out this equation, and this equation. So we must use D equals VIT plus 1/2 AT squared. Using this equation, we can find that the time is 1.43 seconds. So we need to add this to our table. Make sure you do this before we move on to the next question. So check your understanding, part 2. How far forward will the ball have moved horizontally before it hits the ground? Pause the video and work through your answer to the best of your ability. Make sure that you get your answer for the horizontal distance, not the vertical distance. Okay, hopefully you've got your answer. You should see that our time is 1.43 seconds. And this will be the same time for the vertical motion as it takes for the horizontal motion. By the time the ball hits the ground, it will have moved as far as it possibly can in the horizontal. Knowing this, we have 2 of our 3 unknown values in the horizontal. So we can find that D is 2.1 meters. You can also add this to your table. So we're going to come to the third and final part, which of check your understanding. What is the total displacement from the point when the ball started falling to the point when it hit the ground? Pause the video and see if you can figure this one out just by remembering about all the things you know about projectile motion. Okay, Have you got the total displacement? Well, the key to this answer, which will be, your answer should be 10.2 meters. If you haven't got that answer, I want you to take a moment to pause the video and think, what did I do wrong? Or how can I get that value? Where does that come from? Okay, have you still not got it? Okay, well, the total displacement is simply the resultant, or the addition of the horizontal and the vertical distance. What we want to do is to draw a vector diagram and combine the two. 2.1 minus 10. Now, if you take the square root of the sum of the squares of these two answers, negative 10 squared is 100, and 2.1 squared is 4.2, approximately, or is 2.1 squared. When you find the square root of that, you'll get an answer of 10.2 meters. Hopefully, at the end of this video series on projectile motion, you now feel confident to answer all of these learning objectives. If you have any questions or would like me to go through a specific worked example from previous year exams in NZQA website, please do leave a comment in the comment section below, and do watch our future videos.